Okay, so this lesson is going to get into probability distributions more, but we're actually going to start with measures of central tendency, mostly to make sure we're all caught up and familiar with those little kid terms from a long time ago before we take our SAT test. So, on Worksheet 8, we're not going to get to the worksheet for a little while, so just kind of hang tight with me to go through some distribution data descriptors. Wow, alliteration, huh? Speaking of alliteration, mean, median, and mode. Those are familiar topics, right? So one of the things you're going to be asked to do is to know how to find mean, median, and mode and standard deviation on a graphing calculator. With the exception of standard deviation, finding mean, median, and mode by hand is also a skill that you're going to be expected to be able to do. We're going to talk about how spread out the data is and which measure of central tendency is a good descriptor of what's going on. Mean, median, and mode. Remember, they have very scary looking formulas, but mean is the average of all the values. So you add them up and then divide by how many you have. The median is the number in the middle. So if you were to line them up in order, and then you start knocking them off from the beginning and end until you got to the middle guy is the median. And if there's 2 in the middle, then you find the middle of the middle. So you add them up and divide by 2. Mode is the number that occurs the most often. And there can be more than one mode. And depending on your textbook, sometimes they have weird rules about what constitutes a mode, but for most textbooks, as long as it has 2 or more, that is that. It's a mode, but it has to have the most number. So there's ways to organize your data. Most people just found lining them up works great. If you have tons of data, though, you might want to look at like a stem and leaf plot or something like that. Anywho, I digress. So this is a set of data. They're showing you how they physically found the mean and the median and the mode. So you can just pause the video and stare at that screen for a while if you want. All right. That's the same. Oh, one more. Range. Range we don't talk about too often anymore, but we should because range is important. Now the range they're referring to is numerical range. It's the difference between the largest and smallest data pieces. So if you have an extreme range, sometimes that indicates you have some outliers you have to worry about. So, if you want to practice this during class, I sure will, guys, but I feel like we're good. Let's move on. All right. Measures of how spread out the data is. So the first one that we learned when we were small was the range, which is important, but it gets more exciting because once you look within the data set, there might be some variance between the data values. So this is where we start getting into words like, yes, range, but variance and standard deviation. So standard deviation, they use this symbol to use standard deviation. And then if you square that, this is called the variance. So to this day, I have a hard time with like why variance is interesting to me. Because it seemed to me after a while they kept talking about standard deviation more than variance. So I just remember like painstakingly having to find standard deviation like by hand, and it involved a big old chart. And then I was kind of in this gap generation where the calculators existed, but some of the teachers didn't want us to do things on the calculators, so like we had to do them by hand. And then when we learned the calculator could do it, we were like, oh, thanks. That was a waste of time. So I think you guys still might encounter some moments where in college they're going to ask you to derive standard deviation through a series of tables, even an Excel spreadsheet. Which is a little frustrating because everything that you would use to make the tables could also calculate standard deviation. So I'm not going to make you calculate it. We're not in stats class. We're just doing an overview of all the topics. But I hope if your future stats professors have you do it by hand, that's because they're using some extension on the topic. They're asking you to think more in depth about it. They're having you solve for a missing piece within the formula, something other than just what equates to busy work. I'm sorry, professors. I'm sorry. Okay, so one more topic on the screen, though. If they notate it with an S, okay, instead of that weird Greek letter, which I think it's a lowercase sigma. I always forget that one. That is representing the sample standard deviation versus the population. So this is for population. This is for sample. We are not going to get into that real crazy here in PreCalc. When you go on to stats class, that's one of the major topics that you have to cover. Are you looking at a sample or population? And then because of some other rules, can you claim it's like the population even though it's a sample? So we're not, oh good, they told me it is sigma. Yay. So And you know my handwriting is kind of awful, so you're going to see me write my version of sigma, and you just kind of get used to it, right? It's the square root of the variance. So now you ask, what is variance? Oh, I don't know, what is variance? It's the average of the squared differences of the mean. So there's a really cool graphic example of what variance means. It's the distance from, well, I'm not even going to approach this. So if you look in your textbook, or actually just Google like images of standard deviation or variance, they have some really cool visuals where they calculate the distance between like the data value and you know what the estimated data values would be, and the difference between them, and then they square them, and they show you why this formula works, and it's really kind of quite cool, and I hope you have a chance in stats to go through that. All right, these are the formulas for population and sample standard deviations. Not going to use them. There they are again. Still not going to use them. We're going to be using the calculator. All right, so this question here is someone doing it by hand using the formulas. But I'm going to tell you a little secret. Even though they, quote, did it by hand, they probably also used their lists on their calculator to do it. So this is where I get really annoyed with why. All right, so deviations are telling you how spread out the data is, how far away from the mean you are. We're going to get into more about standard deviation when we look at the normal curve. But it's just telling you how spread out the data is. That's the general idea for us for now. When we represent them as what's called a box-and-whisker plot, the deviations are, or how spread out the data is, the variance is easier to see because you can see where the bulk of the data is and where the median lies, and you can make a claim based on that. Box-and-whisker plots, as like they look like little kid graphs. I know, they look really dumb, but they're super helpful when you're looking at your data. So I'm going to skip over all this if you don't mind. I'm trying to find where your notes pick up. Here we go. All right. In your notes, and this is Worksheet 8A. So it says classify these variables as discrete or continuous. So a discrete random variable can take on finite or countable numbers. That's the big one for me, countable numbers. So I'm looking for generally whole numbers, could be integers technically. Continuous random variables can take on an infinite number of possible values within a defined interval. So they don't say it, but the keyword in my brain is decimals. If you can measure this variable with a decimal or a range of decimals, like 0.2, 0.218, that means you have a continuous variable. So here, if it's randomly selected classroom, so gosh, I know better than to cough. I'm so sorry. Okay. The time it takes for a randomly selected classroom to reach 68 to 60, that is technically a continuous variable because time can be measured, you know, like within minutes, within hours, within a fraction of a minute. So you can say like, or a second, you know, 28 minutes, 12.3 seconds. I don't know. I'm making stuff up now. So the point is you can get smaller and smaller with your increments. There's not like a finite number of things you can answer. However, on the next one, the number of photographs taken by a photographer, well, they have physical limitations, of course, but you can't say I took 4.8 photographs. You can say you took 4 or you took 5, but you can't say 4.8. So this is what a discrete random variable would look like. Countable. This is crossed off, so we're not going to think about it, I guess. Where do we pick up again? Oh my gosh, this is all crossed off. I don't think we're going to cross this off in class. Let me come back. Where do we begin? Let's see. Probability distribution for this book question. There we go. All right, I'm going to delete that. So this is on your notes. Let's take a look. It says the number of books bought by 100 randomly selected bookstores. Okay. So what they did here is they tallied up how many books were purchased, and the answers came out to either 0, 1, 2, or 3. And then they looked at the frequency. Now this is written as probability, like 45%. So then what they did is they multiplied that by how many people were actually sampled, and they came up with this frequency table right here. So either one of these tell us things. You know, we could look at this as a distribution where it tallies up frequency, and we can look at a probability distribution. So what do they want me to do? They want me to construct a probability distribution. Okie dokie. Oh, so actually they started with this one and they went to here. My bad. Excuse me. So if I'm constructing a probability distribution, I'm going to try to sneak one in over here. If you ran out of room, I apologize. You've actually already done this before. Quite a few times, in fact. So the only answers that we could have been given were 0, 1, 2, and 3. So I'm going to say this is 0, this is 1, this is 2, and this is 3. Basically, you're making a bar graph, guys. Now they want a probability distribution, so what goes up the dependent axis is, technically you should go 0 to 1, because probability can range from 0 to 1, but I notice my probabilities don't go very high. They only go to 0.45. So I'm going to call this, whoops, 0.1, 0.2, 0.3, 0.4, and since I can't graph, this is all a moot point because it's going to look so horribly ugly. Okay, 0.45, the bar would reach. You know, and I'd like to blame it on the tablet, guys, but I drew this on my paper and it's not really any better. Alright, 1 is going up to 0.3. Totally. Nailed it. 2 is going up to 0.15. Oh gosh. And then 3 is 0.10, 0.1. So very ugly. Okay, can't even color. I hope my elementary teachers never see this. Okay, so this is our probability distribution. And in the upcoming lesson, we're going to talk about skewedness, but this has a definite skewed right direction here. We'll talk more about that term later. And then they want me to use my calculator and find the mean, standard deviation, and the variance. So what we're going to do on our calculator is we're going to enter, excuse me again, we're going to enter this into list 1 and this into list 2. I'm going to pause. I want you to do the same thing. Pause the video. Enter this data, list 1, list 2. I realized before I went I should have shown you where you enter the list. To remind you, you go to stat, and then you go to edit. And I've already entered mine into list 1 and list 2. This is old data in list 3 and list 4. Just ignore it for a moment. Alright, so pause the video again if you don't have them entered yet, but we do. So after that, we go back to the stat menu, and we're going to go over to calc and choose one variable stat. Now in the newer calculators, it gives you an option to fill in if one of them is your frequency list. And remember, list 2 was our frequency list, so that's why I entered them that way. And then we calculate, of course. There you go. So x bar, that means the mean. You want to write some notes to yourself on what this means. Okay, there's our mean. This sigma, capital sigma, is the sum of all of our entries. And remember how, like, we put in the whole number version of it, it understood that that was out of 100 because the calculator actually added up all the frequencies and can determine the probability decimals. You know, it didn't have any issue with that. Alright, this right here, this is the sum of x squared, which is something that you would need if you're using one of those amazing formulas that we're not going to use. So the sample standard deviation is 1. We're actually not going to be using that one in our pre-calc class. We're going to be always looking for the population standard deviation, which in our case is, we'll just say 0.99 if you don't mind. If I keep going down the list, let's get rid of all that. It's going to give me some other information, okay? And keep going, Abruzzo. N is the number of things in your list or your frequency, so there were 100, we knew that. The minimum was 0. Q1 is called the first quartile, so if you take all your data and you chunk it up into quarters, like 25% of the data, Q1 0, median 1, Q3 max. That'll come into play when we do box and whisker plots later, so we'll save that talk for later. Alright, so the other question they asked us for, which, stupid me, is one of those things that's already answered. The standard deviation, now they did it by hand, we're not doing that. The mean was 0.9, standard deviation is 0.99 something, and if you square it you would get the variance, so I forgot that was the one that was already done for us. Alright, this one is, let's see, this is on your test, on your notes at least, so let's go ahead and do this one. So what I would like you to do is get this information into list 1, this into list 2, and then if you're using your newer operating system, you're going to put list 2 as your frequency list. I want you to go ahead and enter that data. So you're going to pause the video, of course, and then once you're entered, we're going to go look at something. It's going to be very exciting, right? All right, so our data is entered, as mine is, in list 1 and list 2. And you know, I should have backed up a moment because I believe the question asked for a probability distribution. So what we're really supposed to be doing is determining this to be a probability. So if I add up how many we have here, let's see, I should be able to add this, right? 12, 15. So if I divide each of these by a 15, gosh, my handwriting gets better and better, right? Alright, so we're going to get these little tiny decimals, which, I'm going to use my actual calculator. Alright. So this is 0.4. Then 0.33. That should be 0.2. I should be able to do that in my head, huh? 1 divided by 15 is 0.07-ish. It doesn't matter, because when I go to graph this, it's going to be awful, right? So we could totally do this by hand, just like we did the previous one. What I want to do is show you on the calculator, where you can get a good visual of the histogram, essentially. Or it's a bar graph, technically. Anywho, forget that. Go to y equal, actually go to your stat plot. We're going to turn on plot 1, and then I'm going to choose the one that looks like a bar graph or a histogram. And then once you choose that one, it gives you these options, and you can fill in x and frequency list. So remember, we had x into L1 and frequency into list 2. And if you entered them as the probability numbers instead of the frequency, totally fine. Because when you hit zoom and then stat, so 9, it's going to show you that. So that's a neat little trick if you want to look, like if your question was to look for skewedness and you didn't want to graph everything and count everything up, this is kind of nice, right? So, I don't know if you're impressed by that or not, but that's what we could have done to get a visual for it. But remember, guys, if it asks you for the probability distribution, what you're really supposed to be graphing is the probability of these answers coming up. So each of your bars would go up to the probability amount. Find and interpret the mean. So we did that one variable stats business on our calculator, and I think I already did this, so I'm just going to steal my information. I got a mean of 0.93, and then I have a standard deviation of 0.93 as well. They happen to be the same, it's not always. But our variance, if I was to square this, comes out to 0.86 roughly. I don't know why they want the variance. It's not like we're going to do anything with it, but there you go. Maybe if you're comparing two probability distributions together, that's the only thing I can come up with. And remember, binomial experiment. We saw this on a previous lesson. You're either going to have success or failure. And we saw this formula. And then apparently there's a whole nother formula you can think about. Super fun, right? But remember, our calculator does that binomial PDF is the one we had been using. Feature that tells you the probability of a specific set of successes in your experiment. We have not used Binomial Cdf yet. I don't think in our class we're going to use Binomial Cdf. So back to our notes here. There's a survey with 20%. Where is this at? Oh, it's crossed off. Well, let's not do it, but let's talk about how, like, we already kind of did this on the previous lesson. So if you need a refresher on binomial probabilities of experiments, we did this, right? So the question says find the probability that at least 4 people said yes. That would be probability of 4 or 5, right? So we'd have to figure out what these were, and we'd have to add them up, which apparently someone already did, so that was nice. What they did, though, is they somehow calculated those binomial probabilities, and remember us, we were going to be super duper duper lazy, right? So we would have been doing the binomial PDF feature. N was 5 in both cases. Probability of success is 0.2 in both cases, but this number was going to change. So like the first time we did it, we did 4, and then the next time we did it, we did 5. And we added up these 2 probabilities, which gives that teeny tiny probability. So there you go, nice refresher of binomial probability. This one, let's go ahead and do. We found 60% of Americans who were victims of healthcare fraud happen to be senior citizens. So 6 victims of healthcare fraud were chosen at random. So this is how many trials we're doing here. That's our N. And their ages were recorded. We're not going to construct any sort of distribution if you don't mind. We're just going to use the probability distribution. Find the probability that at least 3 of the victims were seniors. So for the way we've been calculating them, what we're going to have to do is find the probability that 3 of them were seniors, find the probability that 4 and 5 and 6 were seniors, and then when we find all of these, we're going to have to add them all together. So a little tedious. Those of you who have more exposure to stats, the other option is you could use your Binomial Cdf formula, but remember that measures to the left of the curve. So you would have to do Binomial Cdf up to 2, but then you'd have to do the complement to that answer. So like 1 minus Binomial Cdf of 2 successes. If you don't know what I'm talking about, that's because you haven't had stats. So go ahead and pretend you didn't listen to the last 20 seconds. Okay, so in all of these entries here, guys, it's going to start off the same. We're going to have 6 trials. Success in this case is going to be that 60% were senior citizens, right? So 0.6. And then this last number is what's going to change. So we're going to calculate each one of these. We're going to put a 3 in, we're going to put a 4 in, we're going to put a 5 in, we're going to put a 6 in. I did this, so if you don't mind, I'm just going to kind of jot down over here what I got. I got 0.276, I got 0.311, I got 0.187, and I got 0.047, and when we add all these together, add them up, you get approximately 0.821. So an 82% chance that at least 3 of the 6, so at least half of the people we chose were senior citizens. Poor senior citizens getting victimized by those horrible insurance fraud people. Okay, testing. Mr. Hanlon is a 5-question multiple choice test given to his students, and there were 5 choices for each question. Ashley guesses the answer on each question. Oh, Ashley, that's such a bad idea. Alright, so what's the probability that Ashley gets exactly 3 out of the 5 questions correct? So on our calculator, this is our binomial PDF. And hopefully you're lucky enough to have the newer operating system. But it is 5 questions, and if there's 5 choices for each question, she has a 1 in 5 chance of being successful. So you can write that as 1 out of 5, or you can say it's 0.2, it doesn't matter. And then this time she's going to get exactly 3 right. Well, I got bad news for Ashley. I don't think she's got a great chance of this happening. It's 0.0512. She got a 5% chance of getting 3 right. I shouldn't laugh at that. That's not funny. But that's why you don't just guess. Study, Ashley. My goodness. All right, so what would change if all of a sudden now there's only 4 choices on the test? So a little better chance, Ashley. I mean, if you can do these calculations, Ashley, maybe you can just study. I'm just throwing that out there. All right, so the probability of success this time is 1 out of 4. And they want to know about her getting 3 questions right again. Oh man, the pen's not working. There we go. 3. No, yeah, 3. Okay. So, a little better chance. Still not great. It's like 9%, so 0.0879. Oh, Ashley, just study, girl. All right, same thing, except this time now it's true-false. So she's really banking on doing an awesome job on the true-false, huh? Oh, Ashley. Well, now you got a 50-50 shot, so it's a little better. And you think you're going to get 3 of them right, huh? Well, 30% chance. 31.25. Ashley, think about that, girl. 3 out of 5. That's hardly passing. That's terrible. Okay. The next topic that we're going to cover is expected value. What I'm going to do is I'm going to stop this video. We're going to make a new video that's expected value. Have it separate because I have a feeling that's the concept that a lot of people are going to want to have a review on. All right. See me on the next one. Pause.